So let's look at some of these research studies. This first one here this is just a summary published in Pharmacology, Biochemistry, and Behavior. So you see here the highlights. Tyrosine is the dietary precursor to dopamine and norepinephrine. We reviewed 15 studies on the effects of tyrosine on human behavior or cognition. What they found, cognitive improvements can be observed after a single tyrosine load, meaning a strong dose of tyrosine. Number two, behavioral changes may only appear after repeated tyrosine supplementation. So for behavioral improvements, prolonged use was necessary. And then their takeaway, future studies should focus on long-term effects of tyrosine. Here's another human study. You see here 10 men, 10 women subjects underwent batteries 1 hour after ingesting 150 milligrams per kilogram of L-Tyrosine versus a placebo. So they kind of give you a rough estimation of that dose. Depending on the weight of the human, that's somewhere between 7 and 12 grams of tyrosine. And in this case, what we're really referring to is the L version, L-Tyrosine. That's the one that humans take. That's why you see the L here. So L-Tyrosine. Administration of tyrosine significantly enhanced accuracy and decreased frequency of list retrieval on the working memory task during the multiple task battery compared with placebo. In other words, they performed better on the tests they were given. You see here, tyrosine may sustain working memory when competing requirements to perform other tasks. So again, when you overload somebody with multiple things to do, tyrosine helps to sustain working memory. We also see, and that supplemental tyrosine may be appropriate for maintaining performance when mild to severe decrements are anticipated. So takeaway there is, if you've got a big project that you've got due at work, or you've got something major coming up at work, a strong bolus of tyrosine could potentially be helpful in helping you maintain your focus and concentration. Here we've got another study on tyrosine, on cognitive and psychomotor performance. Is 15 subjects. They gave 300 milligrams per kilogram of body weight, so even more than 150. So this is like 15 to 25 grams of tyrosine. And then they subjected these people to extreme cold. And then the outcome, the data support previous findings that dietary tyrosine supplementation is effective for mitigating cold-induced cognitive performance, such as working memory, even with reduced core temperature, and extends these findings to include the psychomotor task for marksmanship. So they had them shooting their guns. Again, military studies where tyrosine helped with performance. Then we have this one, tyrosine, 12 patients with clinical signs of dopamine-dependent depression. So these patients were depressed. It was confirmed that their depression, or that they had dopamine deficiencies. And so these people were treated with oral tyrosine. They used in this study 3,200 milligrams a day. So a lot lower of a dose than what we've seen in some of these other studies. On the very first day of treatment, a return to mood as judged by clinical impression scores was observed. Sleep recordings performed on nights following days 1, 2, 7, and 8 of treatment showed an immediate improvement of those sleep parameters, differentiating the more clearly dopamine deficiency depression from other types of depression. More than 50 patients have now been treated successfully for periods ranging from a few months to almost 2 years. So again, the specific here is that this treatment works if you have a dopamine deficiency. If you do not have a dopamine deficiency, because there are multiple causes of depression, so maybe you're depressed, but if you don't have a dopamine deficiency, using high doses of tyrosine may not be very helpful for you. But if you do, worth asking and talking to your doctor about it, because the downside to taking strong doses of tyrosine is pretty low key. The downside to some of these antidepressant medications is pretty intense. So anytime we have a natural, we would say nutraceutical way to deal with something with the lower risk of side effects or lower risk of untoward long-term effects, obviously that's a better option. Here in this review, this was a systematic review published in the journal Nutrients in 2020 on military personnel. We suggest that tyrosine or caffeine could be used in healthy adults in a military context to enhance cognitive performance when personnel are sleep deprived. So these individuals being deprived of sleep, using tyrosine to improve functionality. Here's another study in humans. This one, 8 healthy male volunteers given 150 milligrams per kilogram, again, somewhere between 7 and 12 grams of tyrosine if you're taking average human weight, in a double-blind manner 1 hour before cycling to exhaustion. So they put these people on a cycle. The results show that acute tyrosine supplementation is associated with increased endurance capacity in the heat in moderately trained subjects. The results also suggest for the first time that the availability of tyrosine, a nutritional dopamine precursor, can influence the ability to subjectively tolerate prolonged, submaximal, constant load exercise in the heat. So these healthy male volunteers were being exercised at a reasonable rate in hot weather, and taking tyrosine load before the exercise improved their ability to sustain that activity. And then you have this one here, effects of tyrosine supplementation on clinical and healthy populations under stress or cognitive demands. This was a review study. You see the summary down here. Tyrosine does seem to effectively enhance cognitive performance, particularly in short-term, stressful and or cognitively demanding situations. We conclude that tyrosine is an effective enhancer of cognition, but only when neurotransmitter function is intact and dopamine and or norepinephrine is temporarily depleted. So again, what they found in their review of multiple human studies is if you had low dopamine and low norepinephrine, taking tyrosine was a good thing that offered benefit. Now, I've seen tyrosine in other ways clinically. These are some of the human trials, but I'm going to give you some of the anecdote I've seen clinically with tyrosine. And so one of those has to do with tyrosine being used for pain. And why is that? We look at some of the newer research studies that are coming out, nothing done in humans, but again, kind of corroborating my experience clinically. So you see here dopamine's crucial role in priming chronic pain. A newly published study found that dopamine is integral to how pain becomes chronic. This could lead to further insights to help treat fibromyalgia and other chronic pain conditions. Now, on that note, if you look here, fibromyalgia patients show an abnormal dopamine response to pain. Again, dopamine is implicated in both pain and modulation and affective processing. These findings provide the first direct evidence that fibromyalgia patients have an abnormal dopamine response to pain. The disrupted dopaminergic reactivity in fibromyalgia patients could be a critical factor underlying the widespread pain and discomfort in fibromyalgia, and suggests that the therapeutic effects of dopaminergic treatments for this intractable disorder should be explored. Well, what does that mean? That means that dopamine helps regulate pain. Pain is very complex. It's not just hammer to your toe and it hurts, but there are multiple nerve receptors. There's inflammatory chemicals that are released. There are different types of nerves that regulate pain and send pain signals. It's super complex, and sometimes it's complex because just the people are different. But what they're saying in this is that enhancing dopamine may actually enhance people's pain response. And when I say enhance the response, reduce their pain. So what is a dopaminergic treatment option? Well, in the case of nutrition, it's tyrosine. What I showed you before here, right, we have tyrosine being a direct precursor to perform or to produce dopamine. And so this is actually interesting too. I want to point a few other things out since we're talking about pain here, but we have tyrosine converting to dopamine, but look at the nutrients. Going back to the cofactors here, these two are two I want you to pay close attention to, the vitamin D and the omega-3, because there have been a number of human studies showing that vitamin D and omega-3 supplementation reduce pain. There's some studies that show that omega-3 at higher doses reduces pain more effectively than non-steroidal anti-inflammatory drugs. I use it on a regular basis in my practice, but is this possibly one of the reasons why? Omega-3 has more than one function, but one of its functions is in this tyrosine to dopamine formation. So omega-3 is important for that conversion. Omega-3 also has anti-inflammatory properties. Same thing with vitamin D. It has multiple functions, but one of its functions is in this conversion. So these two can reduce pain when you give them. Is the reason they reduce pain possibly having to do with improvement in dopamine? Also, iron is another one. So iron deficiency can cause tremendous pain. Iron deficiency depletes oxygen into the muscles and into the other tissues, leading to enhanced pain, and iron also playing a role in the production of dopamine. So I say keep that in mind, because many of you are in pain and you're thinking, I'm going to take some tyrosine. But if you're going to do that, I always recommend you check out the cofactors that help tyrosine do what it's supposed to do, and you probably will have a greater degree of success. Now here's another paper on dopamine as a precursor. And so you see decreased dopaminergic neurotransmission in 22 healthy human subjects using acute phenylalanine and tyrosine depletion. So they depleted these patients of tyrosine and phenylalanine so that they couldn't get to dopamine. And here's what they found. Okay, our findings of an influence of dopaminergic neurotransmission on affective but not sensory aspects of phasic pain suggests that analgesic effects of dopamine might be mediated by indirect effects on pain affect rather than by direct effects on ascending nociceptive signals. Let's make English of that. Basically, dopamine regulates pain indirectly, not through the nerve itself, but indirectly with some other mechanism. That's at least the conclusion of these authors. These findings contribute to our understanding of the complex relationship between dopamine and pain perception. This is, again, dopamine is more of a pain perception versus an actual nerve inflammatory cascade, which may play a role in various clinical pain states. So improving a person's dopamine outcomes. Look, we know people that are depressed. We know people that have psychiatric inflammation. We know people that have poor job satisfaction. These people are all more prone to pain. And one of the theories behind their chronicity toward greater pain has to do with dopamine depletion. Remember, when we do things we love, when we live the life that's right for us, we naturally make more dopamine and our dopamine pools stay higher, and that regulation of happiness has an alteration on the way we perceive pain. So dopamine, very, very important in that regard. And I've seen this be true in my practice for years, helping people with chronic neuromusculoskeletal pain. Now here's a tie-in to celiac disease and gluten. So those of you who are gluten sensitive, research on people with celiac disease, several studies have revealed abnormalities in monoamine metabolism in patients with active celiac disease. So what is a monoamine? This is dopamine, adrenaline, and noradrenaline. That's what monoamines are. So those neurochemicals of stress and happiness. Malabsorption in active celiac disease is linked to brain function and depression via reduced uptake of amino acids. In this case, what are we talking about? Tyrosine. And this study actually also alludes to the amino acid tryptophan, which we're not focusing on today. But for those of you who just want a tidbit, tryptophan is a precursor to serotonin. Serotonin being the neurochemical that helps regulate gut motility and regulates mood as well. It's one that's oftentimes targeted as in pharmacy for antidepressant effects. But at any rate, they found significantly lower plasma tryptophan and lower plasma tyrosine concentrations compared to controls in patients with celiac disease at 1 year follow-up. In other words, celiac disease patients had lower tyrosine. We know that many celiac disease patients struggle with depression and symptoms of neural inflammation and psychiatric disease at a much higher rate than the general population, in part because gluten damages and inflames the brain, but also in part because of the malnutrition, the malabsorption. And one of the things that's malabsorbed with the celiac gut or the gluten-damaged gut is protein. And if we look at protein, is made out of what? It's made out of amino acids. And tyrosine is one of those amino acids. So when we talk about protein deficiency, it's kind of an all-inclusive conversation to include all of the amino acids together, like tyrosine, like tryptophan, phenylalanine, and many of the others. So again, celiac disease patients more common that they have tyrosine deficiencies, and that might play a role in some of their depression. I want to talk about dopamine a little bit more as it relates to the gut, because we can make dopamine from tyrosine. Go back to that diagram that I showed you earlier, and that's a human pathway of production. So human cells can make dopamine from tyrosine. And a lot of that happens in the gut. As a matter of fact, you can see here, based on this study, more than 50% of dopamine in the human body is synthesized in the gut. Now, what we're not clear about is how much of that dopamine is made by us, made by our cells, and how much of that dopamine is actually made by bacteria. The microbiome, the microbes that live in your gut, many of the different species produce neurochemicals like dopamine on demand. So when they sense that the body needs it, they can actually uptick and start making dopamine. Now, one of the things that we've seen going on, let's tie this in and make it make sense. We've seen going on since the 90s is the massive use of the chemicals to enhance the growing of our crops. And the main chemical I'm referring to here is glyphosate. And one of the side effects of glyphosate is it blocks in plants and in bacteria. So in the plant and bacteria kingdom, so bacteria and plants also make dopamine or have tyrosine and make dopamine, among other things. And so what happens is this chemical glyphosate blocks the ability of bacteria and other plants to go through this biochemical pathway called the shikimate pathway, which is the pathway whereby we make these chemicals like tyrosine to dopamine, and so and also phenylalanine is made by this pathway. So you can see, since dopamine is synthesized from tyrosine and its precursor phenylalanine, both tyrosine and phenylalanine depletion by glyphosate in both plants and microbes would be expected to reduce their bioavailability in the diet. It has been demonstrated that dietary reductions of both phenylalanine and tyrosine induce reduced dopamine concentrations in the brain. So we know that when phenylalanine and tyrosine are limited in the human diet or limited availability for humans, we have a reduction of dopamine in the brain. Impaired dopaminergic signaling in the substantia nigra is a key feature of Parkinson's disease. So substantia nigra is just a region of the brain. Parkinson's disease is what we talked about earlier. The bottom line is that glyphosate was actually patented, and part of its mechanism of action is to block this pathway, this shikimate pathway, whereby in bacteria and plants cannot produce tyrosine or phenylalanine. And so when we rely on some of our bacteria within our microbiome to produce these things, but we're eating foods that are doused in glyphosate. Is it possible that that glyphosate is impacting our own bacterial bioproduction of these key amino acids? On the second point, is it possible that this glyphosate is depleting plants of these amino acids? And so if we're relying on plants, especially somebody maybe on a plant-based diet, to get some of our amino acids, are these key amino acids being blocked because they're not organic, because they're loaded up with glyphosate as well? And that's the big question mark. What I have seen clinically is yes. And this is one of the reasons why when we see somebody go from eating a kind of a conventional diet to eating a diet that's rich in organic, real food, right? Getting the processed pesticides and herbicides out of the diet, but eating organic, real food, a lot of times, even without supplementation, these people have dramatic turnarounds and many types of symptoms, but a lot of them, like pain and inflammation, and even in many cases, autoimmune, antibodies drop, additional other kinds of symptoms can go away, brain fog, energy improves, gastrointestinal motility improves, bowel function improves, digestion improves, skin inflammation can improve. So just by making this switch, right, if you're trying to say, okay, maybe I don't want to take a bunch of supplements, but what can I do? Well, eat organic, real food, get the glyphosate out. The glyphosate is limiting our ability to get to phenylalanine and tyrosine, not only through the plant foods that we eat, but also through our own internal bacterial production. Remember, 50% of dopamine in the body is synthesized by the gut, and that includes production by the gut microbiota. Okay, so let's bring in another topic here that can affect the conversion of phenylalanine to tyrosine. So remember, phenylalanine is an essential amino acid that our body can take from our food and convert into tyrosine. So what I want to show you here is research on the mycotoxin, something called ochratoxin A, which is a substrate for phenylalanine hydroxylase. What does that mean? That means that this ochratoxin A, OTA, is a mycotoxin. It's a mycotoxin that can contaminate your home. It's made from different species of mold, Aspergillus and Penicillium. Molds can make ochratoxin A. Again, it's a mycotoxin, and one of the things that this mycotoxin does is it inhibits the enzyme, this hydroxylation enzyme, that converts phenylalanine into tyrosine. And this is, when we look at many people who are subjected to mold toxins, ochratoxin A, these people can be depressed. They can develop more pain, chronic pain. They typically have memory issues. They typically have cognitive decline. So think about all the things we just said tyrosine has been shown in human trials to benefit. It benefits memory. It enhances physical performance. It enhances accommodation to stress. It helps people maintain functionality when they're under stress, because of the fact that tyrosine helps us make stress hormones. Well, this mold toxin blocks the production of tyrosine by the amino acid phenylalanine. And in so doing, we see a lot of the mold symptoms matching deficiency of what we would see with somebody with low tyrosine. And so I want you to be clear about that too, because many of you are in mold and you may have these symptoms and you can take tyrosine and you might get some bypassing of this chemical inhibition of ochratoxin A, but it's not going to solve a mold problem. So my point is, if you struggle with a lot of the symptoms of mold toxicity, which are very similar to the symptoms of tyrosine deficiency, ask your doctor to check you for ochratoxin A and just get it ruled out. Why? I know a lot of you may be rolling your eyes. I can hear the eye rolls. If you haven't been in mold and you don't understand mold, generally you don't want to think about it. But let me just give you one statistic that should alarm the hell out of you. And this is according to the EPA, 50% of buildings in the U.S., this is U.S. statistics, are water damaged. What does that mean? That means they have the potential for mold to be growing in them. The most common molds that grow in water damaged buildings: Aspergillus molds, Penicillium molds, Stachybotrys, which is black mold. But 50%, this is not a small number. And I know some of you may even be thinking, I'm in new construction, I don't have to worry about that. That mold stuff only happens to houses that are old. What we see clinically is that new construction is worse, because the newer construction in today's world, they cut corners and they use unskilled labor to do the work. And so when you have a bunch of cheap labor, unskilled workers building your house, cutting corners, they make mistakes. And a lot of these mistakes lead to water penetration into the house. And I'm not talking about necessarily a broken pipe or a leaky roof. Most of us understand that that level of water merits a major cleanup. I'm just talking about water vapor, because you don't need running water to grow mold. You just need bad construction that leads to increased water vapor. So one of the easiest ways to this isn't the only way, but one of the easier ways to kind of check your house is to measure the humidity in your house. You can buy a hygrometer on Amazon, or for $8, $9, something like that. Or you can look at your thermostat. A lot of thermostats have built in a humidity measurement reading. But if that relative humidity in your house is chronically above 55%, you've got enough water vapor to grow mold. And so I would look at that today if you're having these symptoms of brain fog, fatigue, chronic pain, fibromyalgic-like symptoms. If you've been diagnosed with ME, the condition ME, myalgic encephalitis, because those conditions match tyrosine deficiency, and they also match mold exposure. So just be aware of that.